Good evening, everyone. Welcome to the live session. Today we'll be discussing practice problems from week 11's content. So I'm Polomi. I'm one of the TAs for the NPTEL Natural Language Processing course. And we'll be waiting for 5 minutes for everybody to join in, and we'll start at 7:05. Okay, good evening, everyone. We'll get started. So the first problem we have for today is, so this is the problem. So I'll read the problem. So one of your teachers have asked you to read this book, and after reading the book, you have to summarize it. So we have to answer that under which category of summarization this would come under. So I hope I'm audible. I just wanted to confirm that once. Am I audible? Yes. Okay. So please try this problem once, and then after a couple of minutes, we'll discuss the problem. Okay, so let's start by discussing this problem. So Mradul has answered. So only one of you have answered. I expect all of you to just attempt the problem once. So let's hear from Madhur. So Madhur, you think the answer is C. So would you like to explain?
Yes, ma'am. I'm not sure. I'm not sure about it, but I think the document. I think the book that the professor mentioned over there is mentioned as single document. So I think single document will be there. So option one and three. And one more thing is that the way of summarization is there are two ways of summarization. One is extractive, and the second one is extractive. Extractive, we just select some points or text that is mentioned that is there in the document. And the second way is to extract the information, means to form some kind of information, some new information from by reading the text.
Okay, okay. So yeah, that makes sense. Would anybody else also would like to add on to what Madhur said? All right. So let's discuss the solution. So the answer is C. So before jumping on to why the answer is C, let's just discuss the broad genres of summary. So first is that of extractive versus abstractive summarization. So what happens in extractive summarization is, so here's mentioned, so we take fragments of text. What does that mean? So we take the input document. So input document would be consisting of sentences. So we break down the input document into sentences, and then we pick the important sentences that would be uh, a good summary for our text. So that is what we're doing. We're extracting sentences directly from the text, from the document that we have, and that is what categorizes extractive summarization. Now, if we talk about abstractive summarization, what we do is, so we take the important sentences. Now, what we try to do is we paraphrase it or we rewrite it in our own words, and maybe in that process, maybe we remove some of the text, we merge some of the text, and come up with a concise and coherent version of the text, which would not be an extract, which would not be exact segments that we could directly take from the document. So that is the difference. So we rephrase the content coherently. That is what happens in abstractive summarization. The second categorization is that of single document versus multi document. In single document, as the name suggests, we have only one text document. Whereas in multi-document, we take multiple documents, say all the documents belong to the same theme. Now, based on that, I need to do the summarization. So we fuse together multiple texts and now we perform summarization. The third categorization is that of generic versus query focused. So, given a document, I could just give a general summary of whatever is present in the text. That could be one way that comes under generic. Another one is query focused. Say the user at hand, the user he or she has a specific query. Now, based on that, after extracting the important sentences, I see which are the relevant ones corresponding to the query, and based on that, using reflecting, as it's mentioned, reflecting the user's interest, I produce a summary. That is query focused summarization. So these are the different categorizations. Now, having understood these points, now we can see that what is the uh, answer in this case. So we have been given one textbook, okay, natural language processing with Python. So that means that we are currently operating under the single document genre. Okay, so that is done. So the multi-document options are eliminated. If somebody has unmuted, any doubt?
Sorry, now why can we consider this textbook as multi-chapters or multi-document?
We're considering as a single document. Could you just repeat your question once?
No, it's a basic book can book contains multiple chapters. Why can we consider each of it?
Um, you can, but if you're thinking at the chapter level, I think that would be specified in the question somewhere. I understand where your concern is coming from, but here, since we are directly referring to the book as a single entity, because of that, we are considering as a single document. If you were doing chapter wise fragmentation and then considering it to be separate documents, then you can consider it under multi document as well. Okay.
If we
Hmm.
suppose change the book to a web application or a Wikipedia consider.
Hmm.
We consider whole Wikipedia as a one document.
For a specific topic, I think yes. So if you search for, say, natural language processing, a Wikipedia page would come up, right? And if you click on that, you'll get one single, the entire web page would be one document.
No, I mean to say whole Wikipedia is considered as multi-document.
Yes, whole Wikipedia is multi-document. Yeah.
Yeah. Yeah.
Okay, I mean, you're thinking like you're further segmenting the book into chapters and pages
Yeah.
like that, right? So yeah, I understand, but so here, as far as I think, so here since we're referring to like you read the book natural language processing, we're considering it to be a single entity, so it's a single document. Otherwise, the way that you're thinking that is also valid. Okay. So going ahead with the assumption that we just discussed, so we're considering the book to be a single document. Having said that, now we need to further go into. So now we can do either abstractive or extractive summarization. Okay. So based on that, we have options 1 and 3, and that would lead us to the answer C. So that is why we get this answer. Any other doubts anybody has in this question?
And also it is definition of extract versus abstract.
Mm-hmm.
The extract we don't replace it. We just pick the sentences from it.
Yes, you directly, as it is, you pick the segment from the text and you put it in the final summary that you have, that you produce. Yes. Any other doubts? Okay, I think we can then move on to the next question. So, next question is we studied the LexRank algorithm in this week's lectures. So, the question is what kind of summarization approach does this fall under? So, please try the question, please attempt the question, and we'll discuss it in a couple of minutes. If you know the answer, please post your answer in the chat. Okay, so we'll go ahead with the discussion. Is anybody still attempting the question? In that case, we can wait. Otherwise, we'll go ahead. We see only again only Madhul has answered, so there are 12 people in the chat. All of you can just give it a try. Okay, all right. Let's discuss then. So, yeah, Madhul, you have answered again. So, would you like to again just briefly explain what you think?
Okay, I'm not sure about it. I'm just confused between option A and B. See, one thing is clear that we are expecting information because we are not forming any new information. We are just expecting the words that will be there. So expecting will be there. So option C and D will get eliminated. And if I'm talking about option A and B, then yes, it is in continuing the extraction process. And third thing is generic and query specific. So, I think it is query specific because we are processing about sentences wise. Means sentences that we have, we are processing some let me see TF IDF TF IDF weights we are waiting for it and some kind of things like that. So I think query specific.
Okay, okay. Would anybody else also like to add on? All right. So, let's see what the solution is. So, the solution is A actually. So we understand why it is extractive, right? So we are simply selecting content. So we are simply selecting segments from the text that are most important. It's a multi-document process that we can refer to multiple documents, and and based on that we can come up with different representations. So this was discussed in the lecture, right? And finally, whether it's generic or query specific. So what would happen in query specific is that a specific query would be given to you, a question like a, it's like as sir mentioned. So when it's query specific, it's like a complex question answering task. So but when we saw the approach of Lexlang, which Sir had discussed, there was no query or a question being asked. So it's simply whatever the TF-IDF or the different features, whatever we were using, so they were just to understand which are the sentences which are most important. Because in a sentence, so we would be able to read a sentence and make sense of which are the important words. But how do we make an algorithm understand that these are the important words? So there TF-IDF comes into play, and we average the scores, we find which are the most important sentences, then we perform the extract algorithm and we find the summary. So it's option A, it's extractive, multi-document, and it's generic. Does anybody have any doubt in this question?
Share any slide for this. That's not
uh, Pardon?
did you share any slide for this? Like,
Let's run. Did I share any slide?
yeah.
Yeah, I'm sharing a slide. Is my screen not visible?
Okay, we still see the question of
Okay, okay, okay. The answer is yeah. Okay. Is the solution slide where you were asking for, I suppose.
no, but any slide from the
Lectures.
lectures.
Oh, okay. In the lectures, this is not specifically mentioned anywhere actually. Whether what
So we should not use this like sign approach for anything else. It is a single document. We cannot use.
I think single document is a specific case of multi-documents. If it applies for multi-document, you can also use it for a single document as well. But in the algorithm that you see, so there, sir had shown like different documents, and then for each document, sir had represented it. So maybe from there, this question was asked. So based on that, we came out a document. Okay.
So it is not a restriction that we should use this like stamp only for multi-document and mixed.
So multi-document is okay. Just a second. Just share this.
So the can go to the content page.
No problem. No problem.
And it is taking time for others.
That's fine. Everybody's doubt will get clear. No? So we'll get one step ahead. It's fine. Let me just bring up the slides. Just a second. Yeah. So here you see. So here what we're doing is here. See, each of the sentences are like here. You see the sentences. That would be one document that we are thinking about. So each of the sentences we are representing like this. So so the word and the corresponding TF-IDF score. Now say that you have only one sentence, okay, only one document. Then also you can go ahead with this approach, right? You can still find the sentences. You can still represent the sentences in the document. You can still formulate the graph. You can still use the hypothesis. It's still relevant. So that's why I'm saying. So you can use it for multiple approaches for sure. So multiple document, you can represent all the sentences, and multi-document you can consider multi-document as simply fusing all the single documents. So it's vice versa. So it's valid in both the cases, I think.
And ma'am, one more thing.
Yes.
I just want to clear one more time.
Yeah.
Ma'am, it is said to be generic because it is for the multiple sentences especially. So it is for the multiple queries or I should say all kind of queries. It is answer. It is taken.
So here there is no query actually, nothing, no information, no user specific information. If there was a query, there would be a specific statement asking, okay, so here you see the multiple statements, right? So maybe there would be a query that mentions something related to computation or something. There would be some user input there. So that is not there. So there's nothing mentioned. You just simply given the text, you produce a summary. That would be a generic one because you don't have any other information that is allowing you to further shrink your summary or further refine your summary.
But ultimately,
Hmm.
consider from the NLP aspect of it,
Hmm.
we got to use it prompt and we want to use the search result or whatever.
Hmm.
So we apply inherently this code
Hmm.
to give them a best suited results.
Yes.
So we consider this is
As a generic.
generic, yeah.
Yes, yes. So if you're thinking in terms of prompts, it would be like you simply ask the model to simply summarize. Please summarize and you give the text. Okay. You're just mentioning the task. Beyond that, you're not giving any further specific query. Maybe I'm remembering an example though, but your user query when it is given, it's much more specific. You only have to focus on a particular area or certain lines would only be relevant in that summary. So in maybe there are say 10 important lines that falls under the final summary, but when you give a query, maybe some do not fall under that, and some would get eliminated, and only 4 or 5 would remain. Based on that, it is answered. Um,
Yes, ma'am, we
say,
can continue.
yeah, I was thinking of an example. Um, yeah. mm, Say you have a list of games, right? You have a document on Olympics. Okay, over there you'll have different sort of all different games will be there, right? Say swimming, tennis, everything, whatever there are there in the Olympics. Now maybe when you're saying in the summarization, you specifically mention, okay, give me summary based on this particular game or this particular year. Based on that, your summary would get more shrink, and that is what is users. It doesn't user input there. Beyond that, beyond asking the machine to just simply summarize, you're only also giving specific information based on which it needs to refine its output. That is maybe one example. Um, okay. Yes. Hmm. Yes. So topic signature means, say, uh, given a document, uh, adhering to the central theme of the document, there would be certain words which are much more important. So these were the salient words. Say you're reading about uh, some atomic structure or something, right? So their salient words would be that of electron, proton, all those things are important words. So from there, that is what they're saying. So choose a smaller set of salient words that would be specific to the domain, and based on that, you assign weights to those words. Okay, so that is what it means. So I give an example of say electron structure, but you can think of other examples. Say if you're talking about natural language processing, so here text and different NLP applications that we read about, those would be important. Whereas different aspects of, say, vision or related things, so those would not be very relevant in that context. So given a specific topic, there would be specific words that are very commonly found, or maybe jargons, which are jargons on those domains. So you can find those words, and those could help you find which are the most important sentences. So, what did that example make sense? Yeah, it would need a domain knowledge. Yeah, not manually, but uh, maybe some. Yeah, you'll have a prior knowledge about it. Okay. Any other doubts? Okay. Let's discuss the next problem. So here the question is, identify whether the following statements are true or false. And there are two statements, one regarding maximum marginal relevance, another one regarding query focused summarization. You need to state whether these are true or false. So again, I would request all of you to just attempt this question, and we'll discuss it in a few minutes. Let's discuss. So this time, a lot of you have attempted the question. So let's hear it from some of you. So Madhur, Lokesh, Archana, Suvarna. Okay. Let's start with Lokesh this time. Would you like to comment on why you've answered A?
Yeah, I think it is generic. Uh, in general, I thought about it. NMR is given a query, it will be easy and reduce the redundancy by answering to the problem that has been asked. So with that, the second one is the query it will be less complex than compared to the
Okay.
summarizing and giving the whole abstract.
Okay. 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 Archana, would you also like to add on anything to what Lokesh said? Hmm. Hmm. Okay. 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 How about Suvarna? Would you like to add on to anything what Lokesh and Archana said?
Yes, yes, ma'am. I have opted for option B. So, I will go for the explanation why the second sentence is true over here. So, very focused summarization can be thought of as complex question answering system is true because a simple question answering system just tries to answer the question that has been given. But very focused summarization also answers the question and it summarizes also. So that's why it's can be thought of as complex question answering system and not as a simple question answering system.
Okay. Okay. Yeah. And uh, Madhul had also answered. Madhul, would you like to add on anything?
No, I'm same as one I said.
All right. How about others in the live session? Would you like to just say anything else? Okay. All right. Let's discuss the solution. The solution is B actually. So first part is actually I think clear to everyone. Why is it true? So maximum marginal relevance. The aim of using this strategy is to reduce redundancy while maintaining query relevance. So this was discussed in the lectures as well. So this is an iterative method where we are performing the first. So in summarization, one of the very first preliminary steps is that of content selection. So we perform iterative methods. So first we'll see that before this, we have extracted all the important sentences. And now, based on that, we see that if among the important sentences, there are redundant information present. If that's the case, we revise the scores and based on that, we select the list of most important sentences. So that is what maximum marginal relevance does. And the second one is so query focused summarization can be thought of as a complex question answering system. So here what we are doing is, so here we have given a question, we first see the document, we first check the document, we extract the relevant part, we answer the question, and at the same time we simultaneously even provide a summary of the document. So just echoing what Suvarna said. So because of that, we can say that query focused summarization can be thought of as a complex question answering system. So these are again like these were discussed in the lectures and I've directly taken them from the lecture slides as well. So the answer would be B, true and true. So does anybody have a doubt in this?
Text is not simple than summarizing the whole document. So,
Mm.
in a summary of the whole document, it's difficult to identify the relevance.
No, so what happens in query focused summarization is there's an additional step. So given a document, you first extract the important sentences, right? And then you do the summary. This would come under generic. Now, if you have a query, given the important sentences that you extract, you further need to find out the ones which are relevant to your specific query. Okay, and then you need to further perform the summarization. So it adds on a bit of a complexity. Yeah, so as I was saying that, so we are performing summarization, is right. So summarization is given a document, we first need to extract the important sentences. That is what happens under content selection, right? We extract the important sentences. Now, if we given the general set of important sentences, if we go ahead with the summarization, that would come under the generic summarization. But if we are doing query focused summarization, we would have a user query. Now, based on the user query, we need to extract specific sentences that are relevant to the query. Okay, this would be an additional step. Now, given this final set of sentences, now we perform the summarization. So that would be query focused summarization. That yes, yes, yes. Any other doubts? All right, so I think we can go ahead with the next question. Um, so this is the confusion matrix that we would be using. So let me just read this. So suppose you have trained the image classifier with 5 classes. These are the 5 classes. So it's cat, dog, lion, tiger, deer, and the confusion matrix is given. So the labels on this side are the predicted labels by the image classifier, and these are the goal labels. Okay. Now, based on this, we'll be solving a few problems. The first problem is, what is the macro averaged precision? That is the question. I'll post this question in the chat. Yeah. So this is the confusion matrix that you need to read for, and the question I've posted in the chat. So please give it a try, and then we'll discuss it soon enough. Okay, so are any of you still attempting the question? Are you all stuck somewhere? So let me know. In that case, I'll wait, or I'll just go ahead with the discussion. I'm asking this because nobody has yet posted any solution in the chat. So if you're all still attempting, just let me know, and then I'll wait.
You can ask to raise the hand if you're
Okay, so anybody who is attempting, please raise your hand. Okay, I think we can go ahead with the solution then. It's this, okay, maybe this is a different kind of problem. Maybe that is why you all are stuck. Let's just discuss the first one, then maybe from the next one onwards it would be easier. So the first question is we have to find what is the macro averaged precision. So how do we do this? So the first is we need to, so we are given this huge table right over here. From that we need to, from the confusion matrix for each of the specific class. Okay. So and how would the class look like? So it would be, so since we're doing class specific, there would be this 4 cells: true positive, the false positive, the false negative, and the true negative. Okay. So now let's discuss how do we come about for one specific class. So for the cat class, what would be the true positive? The value which is here. So the diagonal value, cat cat. So the goal level was also cat and the predictive level was also cat. So this is 130. What about the true negative? True negative would be all these values. Okay. So so here the goal label is something else, but the model predicted it to be cat. So these are the true negatives. So you sum these up, you'll get 73. Now let's go to the false negative. So the false negative are the ones which were these ones. Okay, so these were predicted to be something else, dog, lion, tiger, deer, but these ones were actually cat. So you sum these and you get 80. And finally, so what would be the true negative? True negative would be all these. Okay, these, you sum these up, you get the number. So true negative are which were not cat and which were also not predicted as cat. So that's true negative, all these. So you sum those and you'll get 815. Similarly, you repeat the process for the other classes as well. We have 5 classes: cat, dog, lion, deer, tiger. For each of the classes, you repeat this. Once this is done, what we need to do, we need to go by the formula of recall and precision. Yes.
1 second. This 2 points will be confusing.
Hmm.
The prediction and the actually is X and prediction is Y.
Hmm.
How do you say this is false positive or false negative?
Okay, so false positive would be, so false positive would be this one. So where it is falsely predicted as cat, where the true label is something else. So that is false positive. So here, when we are talking about the label cat, we only focus on all the samples which have been predicted as cat. So here, these were predicted as cat. All these are predicted as cat, but they are actually different. So they're the other animals. So this is false positive. Whereas
All are false positive.
yes,
The row cat
yes,
plus 2 is other than 130, remaining all are false positive.
yes, 17 plus 9 plus 7 plus 40. So that would be the false positive, 73. Okay, and false negative would be these. So here, so these were actually cat, but they were falsely predicted as others. So dog, lion. So these 15 samples, the goal label is actually cat. So the image was that for cat, but the model predicted it to be a dog. Similarly, these 10 were actually pictures of a cat, but it was predicted as a lion. So these comes under false negative. So these values 15 plus 10 plus 15 plus 40, that gives you 80, which is this number.
But the same thing on the row wise you say false positive, but column wise it is negative all the time.
No. So false
See, it's
positive.
supposed to be cat,
Hmm.
predicted as dog.
Hmm. So here here the predicted label and the goal label is different, right? Here the predicted label is cat, the goal label is different. But when you focus on this, here the goal label is cat, but the predicted label is something else. That is how you determine. So true positive is, so you so when you asked you took an image, okay, and you asked the image classifier to classify it. It classified to be, you asked it whether it's a cat or not. So it said positive. So it said yes, it is a cat. So under that there could be two scenarios. Okay, it is actually a cat, which is true positive, or it is not a cat, which is the true negative one, where it's sorry, it's the false, so it predicts to be as positive, but it's something else, but it's a dog or a lion or a tiger, that is a false positive. So the classifier predicted it to be positive in this case. So that is, so this is true positive and this is the false positive ones.
Absolutely confusing.
Yes, initially this would be a bit confusing. Let me just explain once more. So here we have two things. We have the goal label and we have the predicted label. Goal label is what is the actual, what is, so if you have a picture of cat, what it is exactly, that is what a goal label determines. What is the true value? Now, say you have a picture. You have asked the image classifier to classify it. And now, right now, the only focus we are focusing on cat. We ask it, okay, I give you this picture, is this a cat or is this not a cat? So in one case, the classifier says it's positive. Yes, it's a cat. Okay. Now, when the classifier says, so when the predicted label is cat, the classifier says, okay, it's a cat. Under that, there could be two scenarios. It is actually a cat, and another scenario is it's not a cat, which are these, which are the goal labels or something else. So here, when the predicted label is cat, it means the model is the image classifier is positively predicting the label to be cat. Under that, you have a true positive. It is actually a cat. So this cat, this one. Whereas there's another case where the image was that of a dog, but the model predicted it to be a cat, which is these 17. Where the image, again this 9, and where the image was of that of a lion, but the image classifier said no, it's a cat. So this is what it is. So this is the row where the model said that okay, all these are images of cats. So that is what happens when you go by the row. Okay. Now, so that gives you this true positive, false positive.
Yeah,
Now,
but here with respect to goal label, again, we need every parameters to be trained with it.
every
See,
no, every
yeah,
parameter.
if may given an image and we are asking model to predict,
Hmm.
once it predicted, cannot be unsupervised
It,
because we are deciding whether it's true positive or true negative only with the information.
so this, so so here we use this terminologies only for error analysis. So when we are doing training and all, there we only see what is the goal label, and based on that we do training and all. But after that, when you need these scores and all, there these terminologies come. So so
That
this
can be unsupervised also, right?
the image classifier. In this case, I think so. This is a supervised model. It could be unsupervised, but I mean, I do not have much idea about the image domain, but probably there could be a unsupervised model as well. So here, that is actually the idea of whether it's a supervised or unsupervised approach is not very helpful in this question. They're just given. So we'll be using this confusion matrix to analyze what are the errors. So given any cell, if you take any cell, say this 150 that I'm hovering, okay, let's not take let's take the diagonal. So this means that it was actually, the image was that of this 150 samples where images of lions, and the model correctly predicted them to be a lion. Whereas if I take this 20, it means that the image was that of a lion, but the model predicted to be a tiger. So this is confusion matrix. So confusion matrix will be encountering everywhere, irrespective of. So whenever you're doing some prediction, whenever you're doing some inference and you have classes, there everywhere you'll have confusion matrix.
Yeah, ma'am.
Okay. So we were here. So we had this. So we created the confusion matrix for each of the classes. So we had this. Now will be using the recall and precision scores. So the recall would be true positive by true positive plus false negative. So these are formulas which were discussed in the lectures as well. So simply taken from there. And the precision would be true positive by true positive plus false positive. So when we are doing macro average precision, what we do, we compute the precision for each of the classes and then we simply take the average. So what would be the precision in this case? So let's see the formula. It's true positive by true positive plus false positive. So you take this value divided by the sum of the values in this row. So it would be 130 divided by 130 plus 73. If you do that, you'll get this value. Similarly for dog, it would be 150 divided by 150 plus 57. That gives you this value. Similarly, you do it for the remaining three classes. You take the sum divided by 5 gives you the average. And that would be the macro average precision value, which would give you this number, 0.6433. Uh,
There is no micro average.
there is a micro average as well. We'll be discussing it. We have a problem on it. We'll be, yes?
Yeah.
Okay. Any doubt in this problem? Okay. Okay, I hope it is clear to everyone. Then we can go ahead. Okay. The next problem is what is the macro average recall? Now it would be very similar to what we just discussed. Same procedure, just now instead of precision, you need to compute the recall. So I think now you all be able to try this problem. So please attempt this problem and post your answer in the chat. I'll post this question. You all need to refer to the table. Um, yeah. So given this table, confusion matrix, you need to compute the macro average recall. All right. So, are any of you still attempting the question? You can raise your hand or you can unmute yourself or post it in the chat. Then we'll wait. Okay. Okay. So, should we wait further? Anybody still attempting? I think Lokesh had raised your hand. So, okay.
I'm done.
Okay. Um, okay. So, let's see. Archana and Lokesh have answered. So, let's start with Archana. Archana, would you like to share your thoughts on your attempt at this question?
Yeah. So from previous problem itself, we have separated the confusion methods.
Mhm.
So from that separated confusion methods, I have taken the I have applied the formula that is beta is equal to true positive divided by true positive plus false negative. So the value for true positive for that is 130 divided by 130 plus false negative is 80. So 130 divided by 130 plus 80. So with that I have got 0.6190 plus the recall value for dog is 150 divided by 150 plus 147. So that I got 0.5836. Then the recall value for lion is 150 divided by 150 plus 74. So I got 0.6696. The recall value for tiger is 120 divided by 120 plus 50. So I got 0.7059. Next, the recall value for beer is 155 divided by 155 plus 82. So I have got 0.6540. I have summed up all the values and divided by 10. So I have got 0.6460.
Okay. Yeah, that's correct. So, Lokesh, would you like to add something?
No,
Okay. How about others on the call? Would you like to add on to what Archana said? Okay. Okay. So let's see. So this was the problem. So yeah, so Archana said it correctly. So we computed this table in the last problem itself. So now instead of precision, we are computing the recall. So recall is true positive by true positive plus false negative. That is, we are now summing the columns. So when we are taking, so first we compute the recall values for each of the 5 classes. So what would be the value of recall for cat? It would be 130 divided by 130 plus 80. So that would give us this value. Similarly for dog would be 150 divided by 150 plus 107. That is this column. That would give us this value. Similarly, we go ahead and we compute the recall values for each of the classes. We'll be obtaining these values. Then since we're performing an average, we divide the sum by 5 and that would give us 0.6464. That is option A. So that's how we solve this problem. So anybody has any doubt in this question?
Now the confusion with true negative.
Confusion with true negative.
Yeah.
So true negative is, see, true negative are classes. So when you're talking about cat, true negative would be those samples which were originally not cat, which were originally dog, lion, tiger, deer, and they were also predicted as dog, lion, tiger, deer by the classifier. So they have been truly classified as non-cat. So that is true negative. So negative means non-cat. Negative is said to say you asked the image classifier, is it a cat? So it could be 0 or 1, true or false. So positive or negative. Negative means it's a non-cat. So it is truly a non-cat. So these are the non-cat values. And they're actually non-cat and have been predicted as non-cat by the image classifier. So it's true negative. Did that make sense?
And can we consider that that is we have to eliminate the corresponding tax row and the corresponding tax column, and then we have to sum up all the values. Can we put in that way?
Yes, yes, you can think that is what we're doing also. Yes.
Oh,
Any other doubt? Okay, so we can go ahead to the next problem. So today we'll have quite a few problems which would be similar to this thing that we're currently studying. So the next problem would also be similar. So now we have been asked what is the accuracy of the classifier. We'll again post this question in the chat. You all need to refer to the table. So this is the table. The question is what is the accuracy?
Accuracy again we have to be average for all of them.
Accuracy you're asking?
Yeah.
Accuracy would be considering all the classes. Here it's not mentioned whether it's macro or micro, simply the accuracy is asked.
So individual accuracy, then again average.
Possibly. I will be discussing the solution, but maybe we don't have to do average this time. We have to do average when it's a macro, when we're doing macro, then we have to perform average. Otherwise, you have to consider the whole thing as as one thing, and then you have to do the entity. Then you have to compute the accuracy. Okay, so is anybody still attempting the question? Okay, we'll discuss the solution then. So Deepthi has answered. Answer she has mentioned is A. So Deepthi, would you like to share or comment on how did you arrive at the solution?
Yes, ma'am. Ma'am, accuracy is summing up the diagonal elements of the confusion matrix, dividing the total number of all the classified results. So 130 plus 150 plus 150 plus 120 plus 155. These are the diagonal values divided by total number of elements, which results to 1098. So 705 divided by 1098 results to 0.64207. So approximated to 0.6421 month.
Okay, yeah, that's correct. Would anybody else in the chat in the live session would like to add on to what Deepthi said? Okay, so let's just discuss the solution. So just I would be just repeating what Deepthi said. So it's so what do we do in case of accuracy is we have the true positive and the true negative in the numerators, and the denominator consists of everything, whether it's true, false, anything, everything, all the samples. So that's the total number of correct predictions divided by the total number of predictions. So the diagonals represent the correct prediction. So these 130 samples were originally cat and truly predicted as cat by the image classifier. These 155 were images of deer, and the model correctly predicted it to be a deer as well. So all the diagonals are the correct predictions. So we simply sum them up. So 130 plus 150 plus 150 plus 120 plus 155, that gives you 705. And then if you sum the whole thing, all the numbers that you have here in all the cells, that would give you 1098. You simply divide, you get 0.6421. So that would be the accuracy.
2.2 plus 2 negative.
Yeah.
Yeah, 2.2 is equal to 70.
So that this is the formula when you look at a specific class level. So if you imagine it to be like this, then you apply the formula. When you're considering for the entire, so you're computing accuracy for the entire confusion matrix, then you go by this. So here, true positive, true negative, you can only apply to a specific class. Okay, say you're thinking about dog, then you can say these are the true positive and true negative. Okay. After that, when it's a multi-class scenario, you have to go by this formula. Was that okay? I think you're a little bit confused with all the formulas today.
Yeah, thank you.
Okay. Okay. Does anybody have any doubt in this question? Okay. So I think we can go on to the next question in that case. So now we go to, right now we're talking about macro average precision, macro average recall. Now we'll be talking about micro averaged. So now the question is, what is the micro average precision? So post this again. Please give it a try, and then we'll just discuss discuss it in a couple of minutes. Yeah. So again, this is the table again that is given to you, and you need to find the micro average precision. Okay, should we discuss this question? Are any of you attempting this question? And should we wait further? Okay, I think maybe this problem we just discussed. Then we'll go ahead. Okay. Yeah. Um, So this question. So we are doing micro averaged precision. Previously we were talking about macro average. Now we are doing micro average. So what is the difference? So the difference is subtle. So now what we need to do is, given all these, so we computed these classes in the previous step, right? Now based on that, now what we need to do is we need to create this pooled confusion matrix from all the classes. How do we create that? We just need to sum up the individual cells. So we sum up all the true positives. So 130 plus 150 plus 150 plus 120 plus 155 would give you 705. Similarly, all the false positives 73, 57, 83, 80, 100, this would give you 393. Similarly, you sum up the corresponding false negative for all the classes. That gives you this value. The true negatives for all the classes gives you this value. By doing this you get the macro average table. Okay, now after this it's the same. You apply the precision formula. It would be 705 by 705 plus 393, and that would give you 0.6421, which is the precision value. So is this clear to everyone? Does anybody have a doubt on this question?
How is it said the average number we are not considering number of classes here?
So you're asking why it's called micro averaged. Okay, so the name is so we're again, so here we are doing a sort of pooling thing. We know we are not doing proper average, but we're doing a pooling operation, right? So sort of an aggregate sort of measure. That is why possibly it's called average. We're actually not performing an average anywhere in this, uh, in case of micro average. We only do an aggregation. That is what it would be doing. Whereas for macro average, we're actually doing that.
So the basically ultimate difference is this would be better with it.
So
But
actually, macro average would be a better result because there you're giving equal importance to all of the classes. Whereas if in this case there was a class imbalance, say in some class it was having a high value, so that would take precedence. So that would dominate the overall precision value in case of micro average precision. So usually macro average is better.
Then can you explain how this micro average table you have given?
Yes, yes. So this table you understood, right? These tables that we got, these
Yes.
yeah. So from now, from here, we need to create this aggregate table. How do we do that? So again, we have these four cells. The first cell is the true positive for all the classes. So you simply sum it up. 130 plus 150 plus 150 plus 120 plus 155. So if you do that, you will see that that gives you 705. Again, for false negative, all these cells they correspond to the false positive for all the classes. You simply sum it up again. So 73 plus 57 plus 83 plus 80 plus 100, that gives you 393. Similarly, for false negative, if you do, you sum up these values. For true negative, you sum up these values. Simply sum them up. It's like you're just aggregating everything and putting it in one table. Is it clear?
Yes.
Okay. Any other doubt? Yes.
Ma'am,
Yes.
can you put on some light like when we should go for micro average and when we should go for macro average conclusions?
So if there's a say if there's a class imbalance, say if you have a data set, I'm just giving a random example, okay? you have a data set, again, say 1,000 images you have. Out of this 1,000 images, hundreds are cats and 900 are dogs. You see there's a clear class imbalance. The number of dog images are much, much, much higher than the number of cats. So in this case, the macro average precision would be a better measure. However, if you have the equal, if you have that all the classes have equal number of samples, say you have, say here, for example, let's just, sorry, yeah, so here say, here we have 5 classes, right? Say for each of the classes we had 100 instances. So equal number of samples for each class. This is here all the classes are balanced. So here either one would be good, both micro and macro. So in case of class imbalance, the macro one is better. Yes. Any other doubt? Uh, okay, should we go ahead then? Next problem. Hope it's clear to everyone. Okay. So the next problem is macro average recall this time. So last time it was macro average precision. This time it's recall. Again, I'll post you in the chat. This time it would be easier to do this. So please, all of you can attempt it once. Then we'll discuss the solution.
Ma'am,
Yes. Yes.
in the same way, we will calculate for all the measures like default, precision, accuracy. We have asked about the micro and macro. The same process will be followed.
Yes, yes, yes.
Okay,
But
and
it would be
on the basis of their formula.
yes, yes. But it would be mentioned. Remember, so here it's mentioned macro average and macro average. So it would be according to as what is mentioned. You have to do it.
Accordingly, macro average is much better if your data is imbalanced.
Yes, yes. It gives equal importance to all the classes. So that is why in case of class imbalance, macro is better.
So now, basically, what is the difference between micro and macro?
So in macro, you saw in macro, we are simply summing all these things, right? So say in case of, say the model was, the image classifier was very good at predicting cats and the number of samples of cats is very high. Okay, say there are only 2 classes again. We're going to the dog and cat example again. So say there are 100 cats and 900 dogs. So the image classifier is very good at predicting the dogs. So say with 0.9 precision, the dogs are being predicted. Whereas the cats, the model is not performing good at predicting cats. Say it's very, very low, say 0.4 or something. So in that case, if you see, because there's this huge class imbalance happening, and if you simply use macro average, you'll get a higher value. You'll get a higher precision value just because the number of samples of dogs is higher and the model is predicting dogs with higher accuracy. And at the end, you're simply doing an aggregate. Here, you're not looking at for what class, what is happening. So when you're finally making this table, right, macro average table, you're simply summing all the values up for each of the classes. You're not taking into account, okay, for this class it was predicting properly, for this class it was predicting badly. That is not taken into account. So no, so depending on the class, there's no, or depending on the number of samples, there's no, what would I say? There's no uh, that information is not being captured here. So because of that, this would uh, like give, so if there's a class with higher number of samples, that would take dominance, so that whatever precision value it has, more or less a similar value you'll get for the micro average precision. Okay, so that will dominate. Whereas for the macro average precision, you're taking the average will be somewhere in between the lowest and the highest, so that would give you a much more accurate measure. It would be low in case one of the classes is being predicted poorly.
So simply we will take the average value of it is the lowest and highest value. Or
Could you
Like
say?
in the micro average, we have
Mm-hmm.
taken all just like for the procedure,
Mm-hmm.
all true positive, summation of all true positive, false negative, and negative.
Mm-hmm.
So the same procedure will not follow for the macro average. In the macro average, we said that we will take only the average value between the lowest and the highest. So what is the lowest and
So
highest
that was an
average?
example. So that was an example. You do it for all the classes. In case of macro, you do it for all the classes. You find the precision or the recall value for each of the classes and you take the average. I was giving two classes example. That is why I mentioned highest lowest. In the general scenario, it's not like that. You do on a class per basis. Per class basis, you do. Per class, you compute the recall, you compute the precision, you sum it up, you take the average, and you get the value. So that is macro average. Here you're giving.
Okay,
Yeah.
we will take the average value of recall and precision for every class and
Yes.
divide it by the number of classes.
Correct. Correct. Yeah.
Okay, okay, thank you.
Yes. So any other doubt?
Ma'am, for the macro average,
Hmm.
we will take only recall and precision summations, not anything else. Just like in this example, you have calculated the macro average recall, so
Hmm.
you have taken the recall and precision.
Yeah.
So it is only for this case or for all cases. If we are calculating the macro average for all any other matrices like app1 score or accuracy.
So accuracy is computed on the whole confusion matrix actually. When you're doing precision and recall, it goes on a more fine-grained level. If you're doing on a macro average and micro average, you're going on that granularity, then this is exactly what you need to follow. That what we discussed today. It can be like, as you're saying, it could be extended to other generic cases as well.
Okay, so we will calculate the macro average only on these two values, recall and precision.
Yeah, you can think like that. Yeah.
So if in this person they have asked about the macro average recall,
Hmm.
instead of this, if they ask about the macro average precision, that
Hmm.
we will follow the same procedure and will get the same output.
Yeah, so we discussed, right? We discussed macro average precision also. We just simply compute the precision for each of the classes. We then take the average. That gives us the macro average precision.
Okay, thank you so much.
Yeah, I also observed that all the micro computations are equal in the same way.
Acha, okay, it's coming the same value, is it? Okay, okay. Let's see. So, thanks for the next problem. Which problem are we doing?
Same as the accuracy of the whole model.
Ah, okay, okay, okay. Let's see. So this one, right? We were doing. So we are done with this. We're doing this. Yeah. So only Lokesh has answered. So Lokesh, would you like to say how did you answer this question?
Nothing much, man. What was the formula you iterated for the micro average precision?
Hmm.
Same thing I did for the
Okay. Okay. Yeah. So.
aggregation of all the classes.
Hmm.
Just to be helpful.
Okay. Okay. Yeah. So it's a very similar problem. It would be same thing. So again, so it's actually very much it's the same. So because so here this value and this value is the same, right? So we'll get the same value as the precision. It would be again 705 divided by 705 plus 393, the column, and that would give you 0.6421. So that is the macro averaged recall. For precision, it was 705 divided by the row. And
Is it because of only data or it's the principle itself?
I think
Same
it's because of the
activity.
data. It's yeah, it's because of the data.
So for all the classifier, we won't get the same value.
No, no. Yes, only for
Okay.
this. For the specific confusion matrix, actually. It's very much. Yeah. Okay, any doubt in this question? We were at question 8. Yeah. Any doubt in this question? Okay. Mm, let's go on to the next question then. Okay. So I'll just read the problem once. This is question 9. So it is estimated that 20% of ChatGPT generated texts are fake. Some AI system has been applied to filter this fake contents. And then there's this AI system. It's claiming that it can detect 98% of the fake contents, and the probability of a false positive is 3%. Okay. Now, what has been asked is, if a content is detected fake, then what is the probability that it is in fact real? So that's the question. So please try attempting it. We'll discuss it in a couple of minutes. Okay. So should we discuss this problem? Is anybody attempting the problem, or should we go ahead with the discussion? Okay. I think we'll discuss. Okay. So first, let's just demarcate the events that we have. Okay, so we need to state this final, see the final statement that we have, right? So there are two events present here, okay? And even in the entire problem also, there are two things that has been stated. If we could frame it in terms of events, we would be able to approach the problem in easier manner. So event A is the event that a content is detected as fake. B is that event that a generated text is fake. Okay, so what would be probability of B? It's 0.2. So here it's mentioned. So it is given that 20% of ChatGPT generated texts are fake. Okay, so that gives us probability of B would be 0.2. What is probability of B dash? It's the complement. So it will be 1 minus probability of B. So it would be 0.8. Now, what will be probability of A given B? What is A? Even that the content is detected as fake, given that the generated text is fake. So it's 0.98. From where do we get that? We get it from here. It's mentioned that the AI system can detect 98% of the fake contents. Okay. So if you read it till here, so among the fake contents, among the contents uh, that were actually fake, it could detect 98% of them. So that is 0.98. What is what is probability of A given B dash? That is A is the content is detected as fake given B dash. So if generated text was actually real, it was not fake, whereas but it was detected as fake. Okay. So this is the false positive part that we have over here. So it is 3%. So that would be 0.03. So now we have these values. What have been asked of us is this. So the content is detected as fake, then what is the probability that is it is in fact a real content? Okay. So what is B dash? B dash is complement of this. That is the generated text is real, given that the classifier or what do we have over here? That it was detected as, so there's a model which is detecting it as fake. So we applied the Bayes formula over here. We studied naive Bayes in this week's content. So we applied the Bayes formula. So as per Bayes formula, we could rewrite this as this. Okay. Now, the denominator we need to further expand it. So we need to expand it as probability of A given B into probability of B plus probability of A given B dash into probability of B dash. Now, all of these values we have already computed. So it was given to us, either it was given to us or we have computed it. Now we need to simply plug in the values, and on doing that, we get 0.109 as the answer. So that gives us option B to be correct. So does anybody have any doubt in this question?
Can we put this into confusion matrix?
This, um, I think you can, but this has probability values. So usually when we think of confusion matrix, you can fit the probability values as well. So it can be numbers or probability values, but yeah. So this is actually a naive based problem. So this week, I think one of the lectures was dedicated to naive based. So just an application of that itself. This problem is. Any other doubt? Then we'll otherwise we'll go on with the last problem for today. Any other doubt in this? Okay, I hope it's clear to everyone. Let's go on to this is the last problem for the day. So we have been given summaries. So S is the system generated summary, R is the reference summary, which is given by a human. We need to compute the root1 recall value given these data. So let's try this problem once, then we'll discuss it. Okay, I think we can discuss. In case anybody is still trying and wants to add on, we'll go ahead with the discussion. But anybody would like to add on to anything regarding the problem, if you want to comment anything, you can go ahead, or else we'll discuss. All right, let's discuss then. So here we need to compute the root1 recall. So given the in slides the elaborate formula was there. So here there's only one reference sentence. Ideally there would be multiple reference sentences and you need to do the computation for multiple reference sentences. And in that case you just need to do a summation over all the sentences. And again this is root1, so we'll be taking the unigrams. If it was 2 we would be taking the bigrams. So if we need to compute the root1 recall for one given one reference sentence, what would be the formula? It would be the matching number of unigrams in the reference and the system generated summary divided by the total number of unigrams in the reference summary. That would be 8 by 14. Let's see how. So let's take the denominator first. Let's see what are the number of unigrams in the reference summary. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 words and that makes 14 unigrams. That gives us a denominator 14. And the 8 on top is the number of matching unigrams between the system and the reference summary. So let's see. So each of them are colored. It has a different color. So if you see, so ChatGPT is common, is common, deep learning is common, that is common, is common, neural and network. So there are total 8 unigrams which are common between the sentences. So that gives us 8 in the numerator, and if we do the computation, we get 0.571. That gives us the root 1 recall value.
Common
Yes.
point you take it as unicorns, is it?
Yeah, because it's root 1, right? So because of that, we have to take the common unigram. Was that your question?
I want to say this determine article A is repeated in the summary twice.
Ah, okay. Then you have to just take one of the unigrams.
And this unigram diagram is decided based on number of reference to sentences. Right?
It would be the number over here. It's root 1. 1 means unigram. If it was 2, it was bigram.
We have only used 1 and 2 only, right?
That are the one commonly practiced, but you can extend it. So the formula is the generic formula is for n-gram. So you can use anything. Root L is however more commonly used in practice. The lowest common subsequence one. But yeah. Any other doubt in this question? So we have a few more minutes. So ask doubts in this question or any other question. Or something from the slides as well, we can take it up.
Ma'am,
Yes.
here the reference summary is the second statement that is given in the R.
Yeah. Yeah. Any other doubt?
And in this, when we are going for diagrams, the sequence as well as the diagram comes both as points, right?
Yes. Yes.
Suppose deep learning deep and be same by
Yes. They no, that would be a mismatch. And also one thing I wanted to mention was so there would be an extra session. So so this is the second last live session. Next week we have the live session for the 12th session. With that, all the post content would be over. After that, we would be having one more extra live session. It would be sort of a summary sort of session. So if you all have any doubts, I'll be asking in the next class. So in any topics or anything that you want me to discuss in the extra session, just let me know that in the next session. So if you can, meanwhile, you have a week, so you can go through the lectures or the content, and if you have any doubts in any place, just make a note of it or remember it, so that if I ask it the next week, you can let me know, and I'll discuss those in the final, the extra live session.
Ma'am, could
Yeah.
you explain the query document again?
Yes, yes. So, so query based summarization is you would be along with, so you're given a document which you need to summarize, right? Along with that, you'll be given a query as well. And now you need to perform the summarization such that it's aligned with the query, aligned with what is the user. So query means the user is asking something, right? So aligned with that, you need to now perform the summarization. So say first you extract all the important sentences from your document to perform summarization. And now you need to see which are the ones that answer the query that the user has. So you specifically pick those. Now you perform summarization. Now you make them concise and coherent. You take any of the strategies, whether it's be extractive or abstractive, and then you perform the summarization. So here there's a query guiding your summary, so that makes it a query focused summarization. Is that okay?
Yes, ma'am. And ma'am, the difference between a single document and multi-document means.
So in single document, you would be having one single document which you have to summarize. Multi-document, you will have multiple documents, maybe pertaining to a single theme. They would have the same theme. Now you use all of those to produce a summary. That's the difference.
Multiple theme means multiple topics.
Multiple documents. The topic or the central theme would be more or less the same. To say in NLP only. Yeah.
Could you repeat once again?
Yeah, yeah. Say we are doing NLP, right? So say if you searched NLP on Google, you could have multiple documents. So you could take one of them and you perform a summarization as a single document. If you take multiple, so the search would yield multiple results. If you take multiple documents, same, and they all are for the topic NLP itself, then you do a summarization that is multiple documents.
Okay, thank you.
Okay. Okay. So I think we can conclude our session. If are there any other doubts? Okay. Okay. So thank you everyone for joining the live session. We'll conclude the session.
Ma'am, one more now.
Yes.
Hello.
Yes. Yes.
Ma'am, abstract text means a concise summary of the entire document, right?
Pardon. Just repeat once more. I think there's a background noise. Actually, couldn't hear what you said.
Yeah, yeah. Actually, I'm asking this. Abstract summary means the
Abstract.
concise summary of the entire document that we have taken.
No, abstract means you, so in extractive, what you do is you have a document, you take the important sentences as it is from the document itself and you make it a summary. Whereas in abstractive, you rephrase, you paraphrase it in your own terms and you make a summary. Like if you as a human, you were asked to summarize a document, right? You would read the paragraph, you would write the summary in your own words. So that is abstractive. Whereas if you just pick the sentences as it is from the document, that would be extractive. So that's the difference.
Yeah, yeah. I was talking about the abstract.
Yeah, yeah, abstract only. It's abstractive summarization is the second one which I mentioned. That where you rewrite in your own words, that is abstractive. And since you're rewriting in your own words, you would be eliminating something, you would be merging something. So it would be much more coherent and concrete. So that is abstractive. Okay.
And abstract you said that we can take the same sentence, but more informative.
Same sentence, it's more like the here the abstractive part is coming because it's no longer a ditto copy of what is there in your document. It's no longer that you're not extracting something directly. You're since it's in your the important keywords are you're rewriting it in your own words if you think of it. Uh, so you're rephrasing, paraphrasing. So that is what makes it. That's the distinction actually, between extractive and abstract. Okay.
Ma'am, abstract means that are not retraceable, right?
Abstract means you are rephrasing in abstractive summarization.
Rephrasing.
Huh.
Okay, okay.
Okay. Okay.
Thank you, ma'am.
Yes, yes. Okay. All right. So, okay. So, thank you everyone for joining. We'll conclude the live session.
Thank you.